Hello, everyone. Thanks for tuning in to the Next Frontiers of AI podcast, where we engage industry pioneers to explore the innovations, the strategies shaping the future of enterprise AI. I'm your host, Scott Hebner, Principal Analyst for AI at theCUBE Research. Welcome. Today, we continue our discussions on what I believe has become the defining barrier to ROI in the Agentic AI era. It's one word: trust. Over the past 2 years, we've seen enterprises accelerate investments in Agentic AI and the broader notion of digital labor transformation. The ambition is clear: move beyond automation into knowledge work, where AI agents help humans reason, plan, and make better judgments and decisions. But as we will discuss, our latest Agentic AI Futures Index reveals something sobering. Enterprise AI leaders lack trust in AI outcomes, and few have a trust and governance framework in place to deal with it. So think about that. Organizations are deploying AI systems without the guardrails needed to justify, to audit, and to defend outcomes, especially when outcomes are most consequential. The market signals are crystal clear. The next phase of AI will not be defined by bigger models or more impressive demos, nor the obsession with who's going to emerge alive from the so-called Gen AI wars. It will be defined by architectures designed for transparency, explainability, and accountability, by those that create trust architectures that are built beyond just an LLM foundation to enable reliable multi-agent systems. Simply put, it will be about moving beyond these mysterious black boxes known as LLMs. Joining me today is Magnus Revang. He's the Chief Product Officer at Openstream. Openstream has been at the forefront of multi-agent AI systems built on the notion of planning, reasoning, explainability, and multimodal collaboration. They are actually pioneering the trust architectures that I'm talking about. Their thesis is straightforward but profound. Black box AI is not enterprise AI. And enterprises need an AI experience that's truly matters and that can inspire trust and confidence. If AI agents are going to operate in high-stake environments, then explainability cannot be an afterthought. Knowledge ingested and data provenance cannot be casual. And of course, you can't have governance as a bolted-on afterthought. It all must be architectural from the get-go. So Magnus will help us understand all this and what really needs to be done to create a real trusted system and avoid these reliability traps that enterprises are creating for themselves. And you'll see that there is a new generation of specialized, transparent multi-agent systems that are on the horizon here. And Magnus is going to help us understand what that is all about. So let me bring up Magnus. Welcome. Thanks so much for taking the time to join us today.
Well, thanks for having me, Scott. This is exciting and a topic I love talking about. So,
yeah, I appreciate you taking the time. It's getting late there, right? Where are you exactly?
I'm in Norway. I work out of Europe, and but we have offices in Australia, in India, and in the US. So it's kind of in the middle of where all the action is. I'm a perfect time zone to capture the early morning and late evening meetings.
Yeah, I've been following you guys for some time. Even when I was still at IBM. You guys got a really great story. Why don't you just give us a little bit of background on where you are now, how you got here at Openstream as the Chief Product Officer, and just a little bit about what you're helping your clients achieve.
Absolutely. So I've always been interested in technology change, right? So in all my career, the changes has come when technology changed. I skipped out of university when the internet came and started working on that. I jumped onto mobile internet later on. Of course, that was 1999, working with Nokia on something called WAP, Wireless Application Protocol. The same slides I used for a presentation in 1999 became relevant in 2008 when the iPhone came. That's when the real mobile internet came. I was briefly into crypto when I first started at Gartner as an analyst, but went to AI very quickly back in 2015 because I saw these first models. We weren't at the large language model type models yet, but they had lots of potential. And when the large language models came, I would say more specifically, when they became instruction tuned, I immediately looked at my list of most promising companies I was following as a Gartner analyst, and I contacted OpenStream and said, "Hey, I need to be building on this. I can't just be analyzing." And so I went to OpenStream as the chief product officer. And with a background also in user experience, that becomes handy. Understanding the AI technology, bridging that to the users, bridging that to the customers, and building systems that have. There's really no playbook for AI. It kind of gets invented while we go, right? It's completely new. It's on the cutting edge or bleeding edge. So you really have to think carefully about all the choices and how to craft these systems.
Yeah, it's one thing I've always loved about you guys is, and I know you're kind of shifting more and more into the reliability side of things, but you've always been really, really strong on the experience with AI agents. And, in the end, you have human beings that rely on these things, and humans are going to trust it and use it more if it is a great experience. And there's a lot of elements that go into that, right? So I think that combination, plus what you're doing architecturally to deliver more trust, I think it's a winning combination, I should say. Experience that people trust, and then doing the actual architectural foundation.
Absolutely. And we have a pedigree back in conversational AI at OpenStream. And one thing that's interesting about conversational AI is that it's basically non-linear. So it's a way to have an experience that might be a long experience for somebody with no domain knowledge, but an expert user will be done in 3 turns, right? And when you look at it from that perspective, instead of a conversation, think about it more as an experience that is unscripted and non-linear. You can start to add elements back in from regular UIs. So you can have these micro applications, you can point on the map instead of asking for a location. You can do things like that and still have this unscripted way through flows. And that is really, when you look at sort of how this is affecting the experience of users versus machines, that is what you bring from the conversational aspect. And of course, what we communicate, if you go from text to voice to emotions to looking at the micro expression in the face and stuff like that, it becomes quite interesting how much information you can get from a conversational interfaces. And
I think of that. I think of the iceberg analogy, right? The experience part, which you guys have a very strong history in, is sort of what people see above the water. But the real hard work, right, is under the waterline, which is the architectural elements that we're going to get into here. And that combination, like I said before, I think is an awesome position for you guys to be sitting in. So let me just take a couple minutes here just to kind of set up for the audience kind of the premise here of what I think we're going to get into here. And it starts with this notion about LLMs being a black box. And, I think there's more and more realization that you got to be careful what you trust them to do. And just recently, actually, and I talked about this on the previous podcast the last 2 actually, there's been studies that have come out from Carnegie Mellon University, Oxford, MIT, Johns Hopkins, and I think Northeastern University, all in January. Actually, one was at the end of December, but generally in January. So brand new studies. And basically the conclusion was that the explanations that these LLMs produce, generally through using RAG and chain of thought, it's fabricated or made after the fact. And in Johns Hopkins found that 74% of the time, it doesn't really reflect the reasoning process that it went through. So it's almost like justifying after the fact the outcome or the decision, not truly understanding what that decision was and how it was derived. And that creates the so-called reliability trap, right? I would add to that. It's
not surprising, those findings, by the way. We see the same thing when you don't build systems around it. So,
yeah. And when you look at like the top AI universities in the world, right? MIT clearly is up there. I think Carnegie Mellon is probably one of the very top. John Hopkins is up there. So these are really strong AI universities that are coming out with these studies. I encourage everyone to go take a look at them. And it's not that LLMs aren't absolutely critical. They provide the fluency and the coherence, right? You need that foundation, but I think the notion here is when they're used alone in an agentic setting, you're setting up a trust issue. And this data from our most recent Agentic AI Futures Index kind of tells the story that I think we're going to dive into a little bit in more detail here. One of the questions we asked on the far left was, and this was 625 AI, pre-qualified AI leaders in enterprises. It was Europe, Canada, North America, and cross industry too. And basically, only 49% said they had a high degree of trust in the outcomes that the LLMs were producing, particularly when it comes to relying on them for decisions. So that's a low trust index. When asked the next question of, well, do you have a trust framework, governance framework in place? Only 29% said they had one in place that was standardized across their organization. But 73% said that is a strategic investment priority over the next 18 months, which indicates that, Magnus, where you guys are heading is where the money is going to be flowing, which is to address this issue. Mm-hmm. And furthermore, when you kind of look at what kind of controls are needed that will be key to increasing trustworthiness and more accurate outcomes, it is the collaborative nature, right? Human in the loop, if you will, and the ability to, intervene and work with the conversation in the model and help shape it, but also the explainability, right? Both in the high 60s. So I think that all kind of tells the story. And I know you've been at the forefront of this. You've been very vocal about the need for moving beyond the black boxes. And so tell us a little bit about your perspectives on the context that I just sort of set up here.
Absolutely, and I think it's boils down to this, right? It's a very emerging technology space, and we kind of lack a lot of language to talk about AI in the right way. Mm-hmm. So when we kind of look at the whole field of AI, there is a lack of taxonomy, lack of categories, a lack of qualifications and stuff like that to really analyze where a new best practice or emerging practice, if that is applicable in other settings and stuff like that. So if you bring up my one of my graphics, the matrix, if you would.
The use case one?
Yeah. So I like to kind of break AI use cases or the needs of AI cases into two sort of dimensions. One is one of control, right? So some AI use cases don't need a lot of control. If I do meeting summaries, for example, I don't need to have a lot of guardrails and controls and stuff like that to do a pretty good summarization. I can do that in a low control setting, right? There's no laws that governs the summary of standard meetings. There are some for board meetings and stuff like that, but that's another thing, or political meetings. But for most sort of standard meetings, you can get by in a low control environment. If I'm just logging into a chat bot, like an instruction tune model or something like that, I'm in a low control environment. I'm not in an environment where there's compliance issues, where I have to be able to answer why it made that decision or why I believe this and stuff like that. So we have this low control. But in a lot of cases, in a lot of industries, you're actually in the processes and in what we do that has a lot of business value. We're actually in a high control environment, right? Where we need the user to retain control, or the enterprise to retain some control, to follow certain practices, to follow process, to follow laws, right? Compliance and risk and stuff like that play in. So the low control and high control is one dimension. And the other dimension, which a lot of people are not talking about in this kind of LLM world, is that there's a huge difference between AI that is prompt triggered, where I give it an instruction, a natural language instruction. I kind of say, oh, can you do this for me, right? Versus something that is event triggered.
Right.
And
the bottom of the chart here,
event
right?
triggered is triggered by data or triggered by some event in a business process. So the prompt triggered, you can take two prompts with just the plurality of a word changed, and you will get two different answers, right? And it's very non-deterministic. While in an event-triggered environment, you're triggered by the availability of files, of data coming in, of specific things, a button being pressed, stuff like that. And those events trigger predefined instructions, usually multiple agents, and they do it. Now, if you look back, the 90% of all the attention is going to low controlled prompt generated AI. That's where 90% of press is, 90% of people talking about it, about the AI influencers talking about, I tried this and tried that. Now it's moving a little bit towards high control in the prompt generated space with code generation. Code generation needs more control mechanisms. And there's lots of very interesting developments happening on the code generation front of bringing up the control in these prompt-generated models. Now, I don't want to be in that space as a company because 90% of the attention is going there, but actually the enterprise value is in high control, event-triggered mechanisms. So at Openstream, we target things like underwriting, investment banking, private equity, places where you generate a lot of reports and a lot of consequences of things that are happening. The news cycle, supply chains, submissions coming in for underwriting in insurance, big events like earthquakes, fires, stuff like that. Those trigger AI processes, and you need a high control environment because these are compliant rich environments. You have mistakes are costly, and you have this. You have to be able to explain any decision that is made. So in that environment, you also have a really short distance to the bottom line. If I'm able to analyze companies better, then my results for example, private equity will be better. Thus, the AI and ability to generate good results has a direct correlation to the bottom line, right? While in a low control environment, prompt generated, you're giving people an assistant, but the CFO doesn't really see a red line between ability to summarize emails and meeting things or asking questions to the bottom line. So you're kind of looking at this novelty of the technology, but once it becomes more important, when it comes into a place where it needs to deliver value, where I need to be able to show, hey, we saved this much or we generated this much last year because of this system, it's the high control event-triggered systems that are going to do that.
Right. And that's
what where we play.
Yeah. And that's, so, and I think I'm 100% with you on all that. We've gone from like co-pilots, right, doing.
And understand me correctly, though, they're useful, and I
Yeah.
love the instruction tuned models, but from where you want to generate value, that's not it. It generates value for you personally. For a company, there's other things that generate value.
Yeah, so you got this transition going on from co-pilots into automation of known tasks,
Yeah,
into what I've been referring to as knowledge work, which is your high control event triggered. Because knowledge work, first of all, they're consequential, and they're based on people making judgments and decisions, and they want the AI to help them. And then to your point, they've got to be defensible and explainable. You have to be able to verify them. And ultimately, you probably need to audit them for compliance and policy and all that. It's a whole different world that you guys are focusing on. And I do my whole life every week is talking to different companies and, studying this stuff. There's no doubt in my mind that this is where this is all going to rapidly evolve to, is going to be in that top right quadrant that you had. Because like you said, that's where the real value is going to come from AI. That's where digital labor transformation becomes real.
Absolutely. And really, there's a huge challenge, right? Which is why I mentioned the code generation as a very interesting thing to look at. And the reason why that is interesting is that the same people that are building the system is also the experts in the outcomes from that system, right?
True.
So the developers are basically building their own tool. They don't need to consult experts and try to translate the knowledge of experts into something a system can use. Now, that's the minority use case in a way, because when you talk about most other use cases, you have to find a way to understand the experts and translate the insights, the intuitions, the knowledge, the unwritten and the written knowledge of experts into a system that can help them, augment them, and even replace a lot of the tasks they're doing. And that is hard because you need to kind of understand the domain to be able to do that. It doesn't, you have to be an AI expert, but you also have to be an expert on the domain that you're approaching at the same time.
So what does the architecture look like in practice that sits under all this? The architecture is going to help reduce that systemic risk.
Absolutely. So we employ loads and loads of AI agents. And these AI agents basically take an expected input and does work and gives expected output, right? So they're very specialized in a way. And not all of them are LLM based. In a lot of multi-agent systems, all of the agents use the same LLM, right? Which means they're just different prompts. We actually use Symbolic AI and other methods inside of the multi-agent system to be able to have a lot of specialists that are solving a grander problem. So for example, take a simple categorization problem from underwriting, which is in underwriting you're required to assign something called an SIC code to a company, and multiple agents are able to do this as a collaboration. One is supplying what does the company we're looking at do, right? One is looking at what SIC codes are available. The third one is what guidelines do we have for assigning SIC code? What's more important? You shouldn't assign this if you have assigned that, stuff like that. And thirdly, you might have an agent that validates what the other agents collaboratively arrive at and say if it's wrong according to the guidelines, we should redo it again with some augmentation. And when you put all these things together, you might end up with something that, if you'd done that with a prompt system, you would just, here's a web address, assign the SIC code, ? Right? we might be solving with 8 different agents doing different things, doing checks and balances on each other to make sure that we're correct and getting out a code on the other end, and that code will be much more accurate. It's grounded in actual data that is found on the website, data that's found on in the tables of what codes are available, and when you look at that, we get a more explainable results that are much more consistent for a variety of input. Because let's say you have, for example, you're going to put a code on Amazon.com. Well, if you go to Amazon.com, you get a website for the store, not the company, right? So you get the store. Now, if you put that in a Copilot and say, hey, give me an SIC score, you will get an e-commerce vendor. But it won't discover that it has a considerable cloud computing arm that is the majority of their a lot of their revenue, right? So it might miss that completely in a Copilot, low control prompt-based environment, while the collection of agents will do that because there's an agent looking at the website. Oh, is this the real website? Or is it a service website, right? Or it's a service website. What's the real website? Let's find that. So you have all these checks and balances, and you have that in systems to solve it. And when you build those architectures, of course, those are built for specific tasks. So we have underwriting and private equity and investment banking as things that is a focus. But really, the architecture allows for a system that is also explainable, because I can go back and say, why did we think this had this code? Yeah, because these things are mentioned on the website. These things are in the SEC filings with their 13F forms to the Edgar system of the SEC, right? And so you can all point towards the data like that, and you can give a really thorough, vetted answer that is much more consistently good in a variety of situations. So that was just a brief example. Yeah, go ahead.
Oh, no, go ahead. Give your example. And
No, that was the example, right? And that's just a really small thing, getting a code like that. When you do the larger things, like let's say you're evaluating what food additives a company has in order to determine the legal risk against food additives that are under investigation by the FDA. You can do agent systems for that. In fact, we have agent systems that do that, and those things, give answers and a thoroughness that simple prompts and simple, queries to a single type of LLM will never get you consistently good answers to.
Yeah, I mean, that's one point that definitely pops out in your content, is the emphasis that you guys have on, knowledge extraction and provenance and grounding. And when I was preparing for the podcast, the Agentic AI Futures Index is I think there's 80 questions that we were asking. And I actually found this one, which I think is very supportive of what you guys are doing, right? What trust and governance controls do you consider critical to enabling trustworthy and responsible agentic AI solutions? And right at the very top, right, data provenance. And then you guys get into transparency and the explainability. And you were just talking a little bit about the policy alignment and compliance also, right? And accountability and so on and so forth. And, those are pretty big numbers. And again, this was I believe this was in the context of what do you plan to invest in over the next 18 months? And this was done in the fourth quarter last year. So it does start to tell me more and more that people are thinking about that top right quadrant that you were talking about. That's where they want to get to. And I think more and more of them are realizing that you can't get there with an LLM architecture only. You've got to build out, right?
They see the problems, but they don't see the solutions yet. That's my experience.
Yeah. Right. And that's where you guys
Oh yeah, no,
help
I'm
out, right?
happy providing the solution, right?
So
So,
so you position, so let's talk a little bit about offerings here. So on Eva,
mm,
which is your platform, it's sort of positioned as a planning based reasoning engine
yeah.
rather than just a completion engine, if you will, right? So what does plan based actually mean in operational terms? Like,
Oh,
is this what
yeah,
hallucination prevention's all about?
yeah. There's multiple ways to think about it, but plan-based means that you're employing a plan to solve something, right?
Hmm.
So, and that plan might change. So when you're plan-based, it means you're looking at a specific outcome, and you're planning towards achieving that outcome. And you have to do a couple of things to do that, right? First off, you need to come up with the plan, but you also need to be able to revise the plan as you go,
Right.
because you might not have the information available. There might be things that doesn't sound right, or so you have to build around it, or have the system itself traverse these obstacles. And plan-based, when you ask an LLM to do a plan, you're relying on world knowledge of that LLM, and those plans are not necessarily any good. They might be hallucinated, and what's
Hmm.
more is that when you ask it to come up with a plan and follow the plan, it might not follow it, but it will pretend it did, which is a common thing, by the way. So you kind of have to combine these LLMs, which I say is all the strengths of LLMs, being able to deal with linguistic chaos, deal with ambiguity, and being very general in their approach, and stuff like that. LLMs have lots of strengths, but they also have lots of weaknesses. They have a tendency to hallucinate in different ways. I think hallucination is a bad word, but they make mistakes, right? They make a variety of different kinds of mistakes, and hallucination is just a catch-all term for all kinds of mistakes it might do. But it has these weaknesses. Now, if you look on the other side of more old school AI, like symbolic AI, that does logical derivations and logic programming and stuff like that, you will see that the strengths and weaknesses are completely opposite. Right?
Right.
The weaknesses of symbolic AI is, of course, it requires lots of manual work. It requires a lot of maintenance of ontologies and knowledge graphs and stuff like that. And the strengths are, well, it's logically consistent. It doesn't make logical mistakes. It doesn't invent things. It doesn't hallucinate. But if you combine the two, you kind of try to combine it in a way where you eliminate the weaknesses of LLMs and eliminate the weaknesses of symbolic AI,
Right.
and try to combine them together, right? And that's when you really get interesting results. So we use knowledge graphs, we use logic reasoning, solvers, and stuff like that together with LLMs and
Right.
thinking models and other elements of LLMs together, and we build on top of that an architecture that maximizes the strengths and minimizes the weaknesses of both methods. And so far, it gives some great results. It's definitely a path we'll continue down.
Yeah, a couple podcasts ago, we were talking about the 4-layer architecture. You have the LLM at the bottom for fluency, coherence. Then you have a semantic layer, right? And then you have the ability to infuse what I refer to as decision intelligence, explainability, some of the stuff you're talking about. And then you have that action layer, right, where the agents sit. And it brings me to another thing that you guys describe and talk about a lot, which is the multimodal agents that type and talk and listen and look. And it's, and you guys have been making the point that that's really critical for scaling these enterprise relationships that people are going to have when they're in these more higher stake environments. So I'm curious to, one, is that what you're saying, the human element to it? And two is, how do you actually maintain the control and the traceability when these these agents are working across different modalities?
Yeah,
Does it seem-
absolutely. It's a great question, by the way, because one thing is that you've seen these new multimodal agents, right? Where you go around with your mobile phone and it kind of comments on things it sees and stuff like that, which is super interesting. But it's a low control environment. Because as an enterprise, I can't say, well, I want to evaluate my living room, right, behind me, and point out what's the valuables I have in my living room that I need to capture for insurance and like a insurance policy for my interior, for example. I can't just take one of these models and tell it to do that, because the interaction layer is tied directly into the backend response layer, and all the thinking and the input and the responses, they're all connected. There's no there's no easy way to interject myself in and say that, oh, you will only look for items except if I say it as a user. Right. So with these kind of multimodal things that we see coming up is that, well, they're really neat and they're really interesting, but they don't have that control layer that an enterprise need to make it into an application that's useful for them. Now, we're adding that control layer. Right, so we do have that. So things we're doing is, for example, we're doing mass screening of suicide risk based on conversations with an actual interviewer. That's an avatar, where it monitors also your how you react and stuff like that, because doing 10,000 screenings a year is cost prohibitive for doing that with a psychiatrist that requires an hour to do it, right? That's 10,000 hours, so you would need 4 full-time psychiatrists to do all the tests over a year. So it's the matter of being able to do it or not do it at all. So these interactions with, when you talk about human avatars, when you talk about being able to detect emotions and have natural conversations, it is important because it is the new way to interact with computers. We do it today, right? Voice mode on ChatGPT, if you like that, and stuff like that. We do it. It's just that there isn't a high control way of actually doing it, where you have control over how to respond, how to react, what's our brand personality, how should we deal with different kinds of situations. You don't have that control in these models that are basically based on a system prompt and training data. I can't really control that as an enterprise. So we're building that, and that is our, what you can say, our UI layer towards these multi-agent systems. A lot of these multi-agent systems, however, is event triggered. But once you, for example, in let's say in underwriting, or in, like, let's take investment banking. So you're triggered by increased chatter on social media about the company, so you automatically trigger the generation of an investment report looking at that particular company, right? So you do that. The investment banker sits down in the morning. There's already a report up. They read it, and then immediately they start asking questions, right? Hey, how many employees does this company have? And suddenly you have a conversation, and both the source data and the report is part of what the assistant then have access to, and you start to collaborate on enhancing it, right? Oh, that's a lot more than I expected. Can you highlight that in the report, right? And suddenly that gets highlighted in, and then you go, well, how is that compared to others in the same industry? So you're asking for one that's outside, and then we can connect it to other data sources to actually answer those kinds of questions as well. And you can start to see that the collaboration, once the product is event triggered and generated, you can have the expert actually enhance the result further by reading and discussing and highlighting things, and collaboratively with AI enhance it. And the goal is that, junior expert should be able to perform like a senior expert, and a senior expert should be able to perform like the best expert you have. So it's about getting those experts up, and then of course sometimes you will have fewer experts as well.
And that all directly aligns back to the survey data.
Yep.
Well, look, so we're getting short on time here. Let me one last question, and based on all the real world experience you have in this space. So what would be like one, solid piece of evidence that you would give execs that are preparing to, operationalize AI in these high stake environments? Like where should they start? What should they do? What should they be thinking about?
So a couple of things. One, include the experts early. You can't make AI that performs well without domain knowledge, right? And nobody that works in AI, your own developers, companies coming in, contractors, whatever, they don't have the domain knowledge either. So you need to involve your domain experts, be it investment bankers, lawyers, underwriters, or claims adjusters, or whatever kind of expert that needs to be involved. They need to be involved early, because that you have to understand what the AI is supposed to do. And one of the most important things is that AI delivers on a scale of quality, right? So it's not like regular IT where something is either accepted or not accepted. No, it actually has a sliding scale of quality. So it can be good, it can be amazing, it can be, mind-bogglingly good. You have you have a scale here, and you can't evaluate that scale without your domain experts. So you need them in early to build the system. Right. And once you build it, build from. Don't rely on the world knowledge of models. The world knowledge is just use the patterns and stuff like that, and not the knowledge. Make everything into closed systems, so closed instructions, which means you supply everything in the instruction that's necessary to answer, and start to include other technology than LLMs alone, because once you have a really powerful hammer, everything becomes a nail, right? But there is a lot of tasks that is simply solved with a regular API call, or solved by a symbolic system, much better than an LLM system. Now, when you combine those, the important use cases are the ones where you don't need, for an enterprise, by the way, is where you don't need the humans to give instructions at all. Because if you rely on the humans giving accurate instructions, they'll become lazy, they will change things up. The Copilot use case is very useful, but it's not necessarily what gets enterprise value or sort of contributes to the bottom line immediately. At least you can't necessarily see it in any meaningful way. So target the cases where, this is triggered by an event. This is core to our business. This is, if you don't do this well, we will lose long term. That's where the value is, right? And think about if I can change that, if I can contribute to that, then I'm actually generating value with AI, instead of just checking the box for I've done 5 AI projects this year, which seems to be some motivation in the market. But but that's where I would start. And I think also start and be ready to fail and learn rapidly. Not everything will be a success out of the blocks. You need to adapt. You need to be able to change up, and you need to be able to try things out and land on the solutions that is actually good. And keep in mind sort of that when it comes to these things, when you see a best practice, be aware that best practice might be for a co-pilot assistant, not a event-triggered assistant. Or when you see an emerging practice, it might be for a low control environment and not for a high control environment. So you need to be able to kind of learn enough to be able to evaluate these things that comes up in the market, and point out that, well, this is not relevant to us, this is relevant to us, this is relevant to our use case, this is not relevant to our use case. So it's a learning journey, and I think a lot of companies would benefit from starting that with the goal of, we will learn as much as possible, but we and hopefully gain a lot of course, if they work with us, they will get business value, but the important thing for most enterprises at this stage is to learn as much as possible, so that they become good users of AI as this technology matures.
Yeah, it's the old saying that the game's played on the field, not in the dugout. You got to get out.
Oh yeah, you can plan as much as possible. As soon as the ball is kicked, all plans go out the window, right?
Yep. All right, Magnus, this has been a great conversation. Thanks so much for taking the time to join us today. Really appreciate it.
And thanks for having me.
You bet. And if there's any one takeaway that I kind of take from all this, and for our listeners, is that the future of agentic AI will not be won by the most fluent or coherent systems. It's going to be won by the most defensible ones, the most reliable ones, right? And there's architectural requirements that you need to build in to enable trust, especially in these higher stake use cases that Magnus was talking about. So these black boxes may be really impressive in demos, but in production, it's the accountability of the systems that's really, what's going to allow you to scale the value. So make sure you all take some time to go check out Openstream at Openstream.ai. I think you will find what they have to offer super impressive and proven in production. And to everyone listening, make sure you subscribed so you don't miss future episodes of the next Frontiers of AI. Until next time, I'm Scott Hebner. Thanks so much for watching. We'll see you on the next round very shortly. Thanks, everyone. Appreciate it.